Hello friends, today I'm going to solve LeetCode problem number 144 binary tree pre-order traversal. In this problem, we are given the root of a binary tree and we need to return the pre-order traversal of its nodes values. Now what's a pre-order traversal? Let me just show you here. So there are basically three types of traversal: in order, pre-order, and the last one is post-order. So these are the three types of traversals that you could perform on a binary tree. Now what does in order traversal means? If you are given a tree, suppose this is a binary tree that we are given and these are the values 1, 2 and 3, then in the in order traversal the result would be 1, 2 and 3 because we traverse the left subtree before we traverse the node itself. So we traverse the left first and then the node itself and then the right subtree. So it's left, the node, and then the right subtree in order traversal. Now what about pre-order traversal? So by now you must have guessed, like, pre-order traversal means the prefix itself says that it should come before, right? What is it? It's the node itself. The root node will come before the left subtree and then the right subtree. That is, it will be the node and then the left node and then the right node. So the value here would be, in case of pre-order, it would be 1, 2 and then 3. So post order, obviously now that would be left subtree, right subtree and then the node itself. So in this case the value would be 2, 3 and 1. Now what are we asked here? To perform pre-order traversal, right? Which means we first print the node value. Basically printing means we add it to the array of a resulting array and then we traverse to the right subtree and then the left the left subtree and then the right subtree. So now in this example, how can we do that? So I'll just write it here. So pre-order means the node itself and then left and then right. Okay, now we have the node, right? We start from this root node. So what do is we print the value of root node. Now we try to go to the left of this subtree, but is there any left subtree? No, there isn't. So what we do is we go to the right subtree. So now this becomes our sub problem. And in this subtree, now where are we? We are at this node, right? So since we are at this node, what do is we print the value of the node before going to its left and right subtree. So the value is equals to 2 here. And then next what we do is we go to its left, right? So we go to its left subtree and then now our problem is more subdivided into a smaller problem. So now since we are at this node, before going to its left, we print the value of this node that is added to our array. And then what do is, since we have already received our answer but our computation is not yet complete, so in this case, now from this node we try to go to the left, but since there is no left subtree, we return back and try to go to the right, but since it doesn't have right, so we return back to its calling node, the parent node, and then here we try to go to the right, because after going to left we have to go to right, as in this case. But since there is no right node, so we return back to its calling node, parent node, and then finally what do is we return our result, which is this value 1, 2 and 3. So now let's write our code. So what I'm going to do is I'm just going to edit the function itself. And what I'm going to check is if the root value is null, then return an empty array, not an empty array, but return result. Okay, we could just return an empty array because that would take in consideration if there is no value in, that is, if the binary tree is null itself. If not, then what do is this is our result. So we push the value of the root and then we traverse towards its left. So left, and then we do the same thing, that is we traverse towards it right, and then finally what do we do is we return our result. Now let's try to run our code. Talking about the time complexity, okay, so what went wrong? All right, pushed. Oh, okay, so I need to pass my result as well, resulting array. Great, let's submit it. So the time complexity here is O of n, because each time for each of the node we are only making one call, right? So we are computing for only n number of times. That is why it's O of n, and the space complexity is also O of n because we are storing our result in this array, right? Hope it was helpful.